My name is Andrew Stein. I'm the co-founder and chief scientist of Distill Networks. I've been in web development for about 17 years and working with NGINX for the last 4. Most of my work is centered around using NGINX as a reverse proxy with an added security logic to it. You may also recognize me from that front video that they keep playing on loop outside, which is super awkward. But in case you hadn't gotten enough of my face yet, there it is again, and there too. Since they paid for my Uber to get here, let's talk a little bit about Distill Networks real quick. So at Distill Networks, we block bots. We stop bad bots and malicious traffic from accessing your website, stealing and scraping your information, clicking on your ads, and spamming your forms. Basically, any sort of automated attack against your website. And at Distill, we have 2 deployment models. You can either add your domain to our global CDN, our public cloud, or you can use one of our appliances. Our appliances are both virtual and physical appliance, but having that appliance is actually what led us to get a lot more interested and more adamant about performance testing. So why we care about performance testing is that when we ship hardware, people expect that hardware to actually meet their requests per second and other performance metrics. So once you ship a box, you really only get so many chances to get it right. So if you're a major online retailer and we ship you a box and we say it can support 10,000 requests per second and it's only in the 8, 9 range, that's a problem. Because then we either have to ship you another box or make other plans to get your load below where we need it to be. So this here is a representation of our initial performance testing. Basically, before we started shipping hardware, we would just fire up something like Jmeter, put astronomically high values for threads, and just hammer the server until it fell over. This was a fine load test, but ultimately didn't tell us very much about how our system was really doing. It just gave us the point where our software couldn't handle anything more. So before I really dive into testing, how we revised our testing, let's talk a little bit more about the difference between just load testing and performance testing. So load testing is basically when you increase load on a system until it reaches its breaking point. And that's what you see happening to this guy here. He loaded up so much weight on the bar, tried to lift it, and failed miserably. The problem is, the only thing he actually learned from this is that he couldn't support that much weight. Not whether his knees gave out, not whether he didn't eat enough in the morning. He just failed. But that's all he really learned. So we've got his maximum, but we really still don't know why that's his max. Performance testing, though, is when you're testing to understand how a system performs under a particular workload. So for all these people on the treadmill here, some are running very fast, some are running slowly, some are running for extended periods of time, some are doing both, some are intervals for high-low. There's a lot of different variation in what they're actually trying to test and what they can actually determine about themselves. This gives you an idea of, instead of testing just when it's the max, how it performs holistically, both over time and at any given point. Now, so load testing is a subset of performance tests, but too often it's viewed as the end-all, be-all. And don't get me wrong, it's super, super important and definitely a key point of load testing, but there's a lot more to just throwing traffic at a box and reading back a number. This may lead you to ask, what am I actually missing by only performing load tests and looking at performance? So what you're missing is a situation like in the picture, where in the foreground, everything looks fine, everything's normal, just a normal person smiling, but in the background, everything's on fire and burning to the ground. Some of the biggest reasons we found why load testing isn't enough is because, in general, load testing is performed wrong. Instead of load testing individual components or pieces of your application, you're just going to the outmost facing piece, firing a bunch of traffic at it, and saying, oh no, this is where my system falls over, and that's the only piece. So you're not actually stress testing or getting information about the components in your stack. You're just getting that outside view of, this is the very most I can handle, but not really knowing how everything else interacts. It's not really representative of actual usage. When you use a tool like AB or Jmeter, what you're really testing is how many raw requests per second can this bot go through and hit my page before my page falls over. But that's not how actual users use your website. They're not just loading one page individually. they're actually loading the one page, which is then loading additional images, which is then loading JavaScript and CSS. So you really need to get an idea of how all of that is performing together versus just the one piece of HTML that you're hitting with your load tester. And also, it's somewhat outdated in modern environments. So between microservices and backgrounding and queuing and auto-scaling, all becoming more and more prominent, just testing for load matters less and less. How much is your load testing actually going to tell you if all your system is reliant on background processes to happen sometime in the background and just hope that they get done before your user actually loads the next page? So to start doing things right at Distill, we really had to take an inventory of all the things we're actually testing for. And I think that's really the most important part and really getting into the nitty-gritty. Especially as teams grow, it's harder to keep track of all the pieces that go into a particular application. So making sure you know all the pieces that you need to get performance data on is hopefully the first and easiest step you can actually take. So in addition to your application server, do you have something serving as a cache server? Do you have a database? Do you have queues that can back up and run down? Do you have a load balancer? And also, taking a step back and thinking, what does performance actually mean for each? Does it matter how many requests per second you can actually serve if your client response time goes in the tank? You know, do you have to worry about queues backing up and then dropping off and worrying about hitting watermarks that you can no longer handle? Like, what is the actual, when you think of performance, what does it actually mean for each of these components? So at Distill, we're fundamentally a proxy designed to help customers block automated bots. One of the important things we look at when trying to evaluate performance are the assets loading waterfalls. So for those of you who don't do any front-end stuff or who are unfamiliar, this is a waterfall graphic, which basically shows how all the pieces of a website load. So you'll see lots of JavaScript, you'll see the base HTML page in there, you'll see lots of images, JavaScript, etc. So for a lot of us, the performance of our system is really only as good as it appears to our end users. And this is what these waterfall graphs try and actually display. So generally, they're really big, or generally front-end developers are really big into these, but they do play a role when we're looking to see how our NGINX box or other servers are actually loading. So if something is causing your files to actually load slowly, a waterfall graph will show that and will give you an idea of the real user impact of that. So on the Distill side, we're serving pages for customers while also adding content to it. So if their baseline waterfall and our waterfall don't line up pretty closely, we can tell that we're having a performance impact that is unintended. The other thing is to dive into how different usage patterns can actually affect your performance. You're really only as good as your slowest usage pattern because you have no way until you test to know how that slow usage pattern actually impacts all the other pieces of your web application. So if your web application, if you say, I can handle 5,000 requests per second, you have to make sure that every part of that application can actually handle it, even your slowest usage pattern. Because it doesn't matter what you say that is, you're still capped by that slowest number. And for us specifically, this is how our platform performs when it's asked to block traffic versus proxying traffic. So getting an idea of performance for us when blocking everything and then slowly moving it back to only blocking percentages of traffic or no traffic at all gives us an idea of, you know, what levels of performance look like at each of those different spots and how it performs under different conditions. One of the things we really like to use for this is the upstream response time variable that's built into NGINX. Because anytime you're proxying traffic as we are, it's important to get an idea of just how much the proxying backend is affecting your times. So if you have a slow response time coming back up, then you're essentially capped by how many requests per second. Because you can only, as a proxy, you can only serve as fast as what you're getting from the backend unless you have some sort of caching layer. It's also very useful for any sort of hard-to-test systems because you can quickly tell as you increase load if this upstream response time starts to cap or starts to keep moving up and up and up, then you start to know that it's not the front-end layer, the front-end NGINX box that necessarily is having the issue, but it's probably something on the back end. And we'll actually talk about an example of when this happened for us a little bit later. Another thing that I really like working into our performance testing is actually both our functional and unit tests. So we've got Cucumber and some code running through the test NGINX harness there. Adding a timing component to these tests can be useful to really get, again, that sort of user impact whenever you're testing something. Making sure that a test that normally runs in half a second isn't now dragging out to 5, 6, 7 seconds as you actually go through and start increasing load on the box. And then the next step is really to instrument all your tests as much as humanly possible. Because you never know, especially when performance testing, especially when throwing load against the box, exactly what your failing point is. So the question, of course, comes up, well, what do I monitor? And the answer is pretty much everything. Everything that you can reasonably monitor, you probably should be. In most cases, you can install a tool like Zabbix, which will go through, have an agent on the box. I think Datadog works similarly, where you can go through and it'll collect all the information, upload it to a central repository that you can then query from. So each of these can help you diagnose particular problems that you may not know you're having, but may impact your performance and how you're serving traffic. So your performance is going to suffer, obviously, if your CPU is pegged at 100% or if your network pipe is saturated. If your memory fills up due to a leak and you start to swap, any performance is just going to be in the tank. Operating system and processes seem like silly things to monitor until you realize that your performance is actually struggling because you've opened too many file descriptors on your box. And now it's fighting in contention and things are failing all over the place. The last thing on the list here is actually your load generation machine. It's really easy to say, oh, I'll fire up AB and just throw whatever volume of traffic or traffic I want at my server. But those things do actually have practical limitations too. So understanding whether or not you've actually maxed out the amount of traffic you can send before going, oh, this is actually the limitation of my application is a pretty major step. So I'd like to bring up a time when our logs, and these are just actually raw NGINX logs, not really modified at all, actually helped us uncover a major performance bottleneck that a straight load test likely would have missed. So before I really launch into that, though, I need to give a little background about our internal performance lab, our performance harness. The lab's built around a 4-box Jmeter setup, with the idea being one box couldn't saturate the load that we needed at 100%. That'll automatically kick off repeated test runs at 25, 50, 75, 100, and 125% of what we expect our load to be on a given size machine. It runs these tests for short, long, and what we call endurance periods. And then on top of that, it runs them against small, medium, and large machines. Because when we send customers actual hardware, we need to make sure that we are provisioned to the point where even if they spike 100%, we want to make sure that our boxes can actually handle that. So knowing what thresholds and how big a box to send actually becomes pretty critical. After all these tests run, what they do is they take all these stored logs and upload them to a shared, in our case, Google Drive folder. And that also includes them going out and hitting our Zabbix API, which then pulls all the processor, network, OS, basically all of those monitoring tools that I had mentioned beforehand. And we did this so that whenever, and so the other piece that it actually does is it goes through and it actually graphs all of these things so that we're not just sitting there looking at raw numbers trying to figure out exactly what's going on. Like I said, it also handles NGINX logs, so it pulls them together and combines them into also graphs, such as this one. So what you're seeing here is a normal RPS benchmark in our performance harness, pulled from the logs of one of our smaller instances across a 15-minute test. And for this, everything looks pretty good. You know, the line itself is all pretty standard, pretty straight across, tight grouping, rarely spiking or dipping. So we can tell that this is a solid performance across. And at the end, if we look at just RPS, we're sitting at like 2,242. We do monthly code pushes, though. So our goal is, in addition to improving our bot blocking performance, also whenever possible, improve our application's performance as a whole. Just because the last thing we want to do is continue shipping slower and slower code and not have any idea that it's happening. So after a month of development, we run our test again, and on this new branch, and we start to see some small but positive gains in performance. So our new build manages to creep up, on average, about 11 requests per second. It doesn't seem major. Granted, it's like 0.5%. But at the end of the day, like any increase in performance that you can get consistently is pretty good. And also, these are smaller boxes, so as we move this code to larger boxes, we tend to see larger and larger performance gains. But like we've talked about, this final RPS number that we're seeing here can be misleading and isn't really a great way of evaluating performance. It can be used to help discover other problems, but again, not the end-all, be-all. So the RPS count was higher, but when we actually went back and looked at all our graphs, we started seeing some pretty bad performance issues. This is 2,253 requests per second. Now, it might be a little tough to see on the graph, but you'll notice instead of that nice tight line all centered around about 2,200, we're seeing these massive, massive valleys across the way, generally where it's in red. So if we remove those valleys, actually, this is a 75 requests per second increase, which is significantly higher. But because those valleys took performance down enough, when we wound up looking at just the average RPS and just looking at that single number, it would have gone unnoticed because it is higher, and we would think, oh, the higher number, much better, no problem. So had this gone unnoticed, we would have had potentially a major problem in production seemingly about every 5 minutes. And these are just those two graphs on the same chart. Like I said, first one looks great, pretty solid performance, very, very minor dips every so often. The second one, much more prominent dips. So that led us to the question of asking, what in the world is actually going on here? So this is one of the graphs that our system collects, which is that upstream response time variable that I talked about before. Now, this is the most helpful one because it actually shows, if you look in the red sections on those same 5-minute intervals, you'll see these big white gaps where the upstream slows down and almost just stops responding entirely as requests are being made. And these are actually charts of every single request that went through the system. So it's not just average response time or anything like that. It is actually a graphing of every single one. So you'll see where we were starting to peak and valley was also at the same time that we were seeing these massive flare-ups and flare-downs in our graphs. And this gave us enough insight to go to our upstream, which is also heavily monitored, and look at what was going on there. And it turns out that in synthetic testing and just load testing against that box, there was no problem with the load whatsoever. But when running this way through our normal platform, it turned out there was something up with how it was opening connections, and the backend box was getting completely oversaturated. So what we had to do is we had to go back, repower our upstream, basically fix the connection issue we were seeing there, and then rerun our tests. And when we reran our tests, we got the same type graph that we saw before, but moved about 75 RPS by average over. So that really taught us two things about our backend. Well, really taught us two things. One, we needed to soup up our backend, and also that we hadn't actually run into a performance bottleneck with our main application. It was just something else entirely that was dragging down performance of the entire system. Another thing that's pretty important, and this kind of goes without saying, but we've seen it happen often, is that people aren't actually recording all of their test results. They'll hold on to them. They'll say, oh, performance looks great this time. They'll hang on to maybe for a week, 2 weeks, whatever, and they'll just kind of throw it away or it'll get lost. That's part of the reason why we actually took the step of going through and uploading all of our files to a shared drive so that all our developers could see it. Now we can actually pull this information down and start doing historical checks on how performance has changed over time. So in general, if you see, I don't know, maybe a 1% dip on a platform release, maybe it's not terrible. 1% is 1%, margin of error, sure, no problem. But if you see over time, over the last 6, 8, 10 months, or however often you do releases, that you start to see that dip gradually go down and down and down, well, now from 6 months ago, you're at 5% or 10% from where you used to be. And that's problematic as you continue to try and build systems that are going to scale. Also, these are all the recorded tests at different load levels as well. So we can really get into the nitty-gritty of if the box isn't fully saturated, exactly what are we, what levels should we be at, and where do we go from there? And because it's shared, our developers can also go through and look at it and really start to take ownership of performance in a way that they hadn't been able to when we just kicked it off to our QA team and they were just running load tests against it and would either thumbs up, thumbs down for too quick or for too slow or fine. And these are just some of the tools that we use that we talked about during this. So a tool like Web Page Test has an API that'll generate the waterfall graphs for you. Alternatively, you can just use something like Firefox powered by Selenium to grab the HAR files that will also give you that accurate sort of waterfall graphic. Because a lot of functional testing is actually done via Selenium nowadays for full-page websites, and this will actually generally something you can integrate pretty well into your normal test cases. And then Zabbix is nice because it has an API that we can go through and pull information out of, though I'm sure any number of monitoring systems also do the same. This just happens to be the one we use. We use CLI chart, which is a Python tool pretty extensively, just because it's very easy at taking log lines and with minor parsing, actually being able to go through and automatically graph all of the things that we showed here. So that's how we can easily make that transition from, oh, here's just lines and lines and lines of data to an actual graph so that people can sort of glance and go and get an idea of how everything is working. And then we use Jmeter in particular, just because we found it pretty easy to automate just from a command line. So we can kick off our tests in our Slack channel, and it'll go through and run performance of everything. But a tool like AB, Loader.io is another tool that we've used in the past just to generate that load. And that's really all I have in particular. Happy to talk about it more, about what we're doing, about problems we've faced. But yeah, that's about it. Any questions? Yeah. So right now, it's about a year since we started. It's a decent amount of data, but at the same time, like in general, Google Drive or Dropbox or Box, the data retention rates, or basically the price to retain that data isn't insurmountable. It's not a huge deal. So just being able to throw it up there and just give people access is better than the like $10 a year it counts for 100 gigs. We've generally gotten more value in that way than just discarding it and not having to worry about it. Oh, sorry. The question was, how long do we retain the log data from our performance tests? All right. Sorry. Sorry? At this point, no. In general, we just rely on our Zabbix monitoring, which has been pretty reliable, and we haven't experienced any issue with. And just the ability to go through and actually pull it via API. So at the end of the test run, basically we say, for each monitored box, we can go through and say, between this time period, pull out all the data that we would possibly need for all of our metrics, and it'll go through, pull it down, then we'll graph it through CLI chart, and then upload it for review. Other questions? No. All right, awesome. Thank you.